Next up, we have CARGATOMIC. Oh, there we go. CARGATOMIC, which is going to be presented to us by Monica Rodriguez and Mitchell Sinclair.
Buenas tardes. Good afternoon. My name is Monica Rodriguez, and on behalf of the CARGATOMIC team, we are going to present to you our startup. First, we'd like for you to take a look around the room, and we'd like to challenge you to find an item for which you can say that was not shipped overseas. It's hard to tell, right? This is because the shipping industry is a worldwide multi-billion-dollar business. But it's riddled with many terrible things. First, we have high fuel costs. It is unreliable because you have delays in your ports, and it is a dirty business. But let's not focus on the problems. Let's solve this. We are the engineering design firm that will couple small modular reactors with big-ass ships. So how will we do this? We will partner with shipbuilders, and we will bring you economical, fast, reliable shipping. The shipping industry is $110 billion. Its delays can cost up to $1 million a day, and new requirements will have you pay double your fuel prices because it will require cleaner fuel. Right now, the global merchant fleet is one of the most polluting entities around the world. It's even more polluting than many countries. New regulations will kick in the following decades, requiring the shipping industry to comply, and they will have to adapt quickly, and we are the rapid response team.
Thank you, Monica. My name is Mitchell Sinclair. I'll introduce our team here. So we have Cliff Giglieri. He's our CEO and board member. Cliff has been an excellent motivator to bring the team to what we are today. We have Monica Rodriguez, who we just met, who's doing environmental and engineering. Pavel Velkovsky, he's our CFO and finance and legal. And Calvin Parkin, he's our CTO, and he is the most brilliant mind that I've met. And Mitchell Sinclair, myself, I'm VP of Sales and Marketing. So, if it's such a great idea, would we have competition? Most definitely. So, currently MAN Engines is developing diesel and bunker fuels. They're looking to refine their bunker fuel and reduce sulfur emissions, as well as doing carbon capture on their ships, as well as Rolls-Royce Marine Division and Weechaw Power, who's partnering with Westport Engines, develop liquefied natural gas engines for the shipping industry. The advantage that we have, though, is that we're a zero-emission engine solution with zero carbon and zero sulfur emissions. So being environmentally friendly is good, all that, but nobody's going to pay for that if it's not cheaper. So our total lifetime operating expenditures are 5 times cheaper than liquefied natural gas or diesel. Additionally, we have very delighting features, including the ability to sell power from the nuclear reactor on the ship when we're at port, meet environmental and regulation requirements, provide consistent operating expenditures. Especially with a low margin business, this is incredibly important. You don't want variable costs because your fuel costs are going up and you don't know what's happening next year. Additionally, we'll be able to use process heat to treat wastewater and ballast water. We'll be able to ship faster, which means we'll be able to make the port call times and avoid up to potentially $1 to $2 million a day per ship in delay fees on a port. So for a technical solution, right now we've looked at NuScale's. We're open to different partners. But right now, NuScale's reactor is 160 megawatt thermal. We'd use that coupled with a steam turbine to drive the twin propellers on a EE Maersk class ship. We would use an AC generator to generate AC power when at port, as well as process heat for that ballast water. We have developed a company roadmap. The first 2 years are design and engineering. Phase 3, we are looking at doing a first full-scale engineering and design for a Maersk ship, with phase 4 and phase 5 doing our 2nd, 3rd, and 4th ships. We've developed a 5-year P&L. We're looking for financing right now for $5 million, and then looking for $15 million of financing 3 years later, coupled with $140 million for the engine propulsion system for the ship. I'd like to now welcome questions and comments. Thank you very much.
Yeah, how do you think about safety on board ship? Yeah.
So part of the reason why we went with the NuScale module was because unlike some of the military ships that use high enriched uranium, NuScale actually goes with 3 to 5%, just like on regular light water reactors. So on a safety standpoint, that's actually much safer, and in a safeguard standpoint, much safer than what's currently available. Yeah, anyone? No. Yeah.
But 3 to 5% guaranteed
Yes.
safety? I don't buy that one, right? So is a passive shutdown on this? Or?
So we'll have a typical solution that nuclear plants go with, which is just higher guns and guards for the ships as well. And that means your cargo is going to be even more secure as well.
From a technical standpoint?
Okay. How often do you need to refuel?
So the NuScale reactors are on a 2-year refueling process, but since we won't be operating at full power during cruising, we'll be able to extend that quite a bit.
What specifically are the laws that are driving your business, the laws for cleaner emissions?
So currently, sulfur emissions, the global shipping fleet is about 50% of those. There's going to be caps on those imposed by 2020, where they're going to look to cut to those significantly. And low sulfur fuels, as well as liquefied natural gas, are significantly more expensive than the current bunker fuels that are used for them.
And another question, will these ships be able to make port in an anti-nuclear country like Germany?
Well, the size of the ships that we're using are, the limiting factor is actually the size of the ship, less the being able to make port in anti-nuclear countries. I think that in terms of countries that actually ban nuclear ships from their waters, there are relatively few, like New Zealand, like perhaps Germany, but I don't think any of the countries where we might, yeah.
The first few ships will demonstrate the safety and reliability of the technology, and then we're hoping that that will speed up the process of getting approved to come into port in other countries.
What were some of the main drivers of costs that you considered in your calculation about cost savings?
Cost savings as far as we're expecting that there'll be emissions caps on greenhouse gases, which there are lots of modifications that can be made to these ships as far as lessening, making them cleaner emitters. But the only actual solution that we're offering is 100% no greenhouse gas emissions, no sulfur dioxide, no nitrous oxide, 100% across the board. No matter how regulations change, our ships will always be ready to sail. Yeah.
And also, LNG right now has about half the energy density of the fuels that are used, and that takes up plenty of your cargo space. And these ships are driven by economies of scale. You need a very large TEU to make it cost effective. So if you have a lot of fuel taking up cargo space, you're also reducing your margins.
In which shipyard do you think you would be able to build a nuclear-powered ship?
Sorry, Alan, I'm going to
In
have
Asia.
to have them.
South Korea specifically, Daewoo.
South Korea is your answer, and with that, we're going to go